Very good morning everyone. My name is Shiva Krishna. We are going to discuss about the aerospace structural dynamics, which is under for this aerospace engineering, which is aeronautical and aerospace engineering. So we are going to discuss about the undamped free vibrations today. So in previously we are already discussed about this. What is meant by damping, what is meant by mass, what is meant by vibration, what is meant by natural frequency, all those things we have been discussed already. If you are missed that, you can go and check with the previous videos. And we are going to see about this, what is meant by vibrations and how it will be going to be affect our particular day by day life, and how it will be going to be modeled, and how it will be going to solve with this particular chapter into this particular lecture, right? So we have been starting with this already. We have been seeing what is meant by vibration and the phenomena of vibrations, which is excitation force, which is example with the spring mass systems. We have been seeing with it, again there will be a simple pendulum. We have been seeing and causes of motions, vibrations. There will be unbalanced forces and couples. So there will be unbalanced forces. If you say there is a extra force is given to the right side and left side there is a less force, so there will be going to be a vibrate, or else there will be some extra movement will be going to happen. So with this we can able to get the vibration into this particular systems, or else by using of these couples, like two forces acting in a simultaneous way. So there will be some rotational movements, there will be unbalanced forces, unbalanced vibrations or couples will be going to be formed into this, right? There will be caused by these vibrations. Dry friction between two mating parts, like there is a hole as well as there is a shaft is there, okay? In between there is some grease or liquid should be there, otherwise it will be going to be some vibration, because if it is turning, if it is rotating towards the clockwise or towards the right side or movement, there will be, so it will be going to be caused with the frictional effect, as well as there will be some rubbing action between. Once the rubbing action, if it is produces, then it is try to get the vibrations into these systems. And wind load may be causes to this vibration in certain systems, such as like a telephonic lines and electricity lines. So as we said, there is a previously, if there is a lines with the teleportation lines is there, so if the wind passes over this, okay, and there will be a some small vibrations will be going to be happen into this particular lines, right? So in this some of the earthquake systems also there will be high vibrations. If it comes, then it will be going to become as a earthquaking systems, right? So here is the some of the examples has been given into this. So here it is the unbalanced shaft. You can check this. There is a unbalanced forces into this couple. So there will be bend will be going to be occur into this. Vibration will be produced by this like this. And there is a excessive clearance. There is a excessive clearance means if there is a shaft is running, but there is a through holes will be there, right? The bearing side there will be holes are very large. Then if the mass is rotating, then it is try to move towards the upward layer and downward layer from these ball bearings. So there will be causes and vibration into this particular motors and models, right? And if there is a electric motor is running, which is having high frequencies, and loads, then it is try to move their position. With the high frequency forces. So there will be a nuts and bolts will be try to lose their positions, because it is try to escape from this original position, right? Which is some examples for this, how it will be going to be, excitation will be going to come and causes these vibrations, right? We have been already seen how the vibration will be going to come and how the natural frequency and what is meant by all these systems we can able to see. So what is the disadvantage of these vibrations? There is a excessive stresses will be going to be increasing to this, where the bushers and nuts and bolts will be extra stresses will be going to come. Once the stresses is comes, then the crack propagation will be going to come. Once the crack propagation is comes, then it is try to failure their lifetime, right? Life is going to be failure, though it will be going to be causes that life of the particular thing will be going to be reduces. Like if there is a high motor running which is daily about 10 hours if it is running, and causing that vibrations once again. Okay, and it is try to move. There is a bolt and nut, it is try to move, right? And once it is moved, then there is a some cracks will be going to be happens. It is try to move means there is a, it's not only directly moves, right? It will be causes some cracks over the body and try to move the particular position, right? Once it is having crack and it is try to growth with the type of vibration, right? Once it is grown means there is a catastrophic failure will be going to be occur into this particular motors, right? So once there is a vibration is occur means there is a decreasing of life is also we can able to expect. So the failure of machines will be going to be happens into this particular type of system. And undesirable noise, there is a large noise will be going to occur. If you see there is a new motor and old motors, if you self observe any new cars or old cars, there is a noise level will be going to be increase into these olden systems, because there is a warm up as well as there is a worn out. The worn out situation will be going to be happen into this particular old cars, older motors, right? So there is a, you can see there is a advantages in these vibrations also. There is a some guitars, you may see there is a music you can play, and there is a vibration free, you can see there is a sorting of stones we can able to say, sorting of coins and everything, and there is a pulverizations as well as there is a chip separator or ball separator will be going to taken into this. There is a riveting and shakers and stress relieving materials. All these will be some of the advantages of these vibration systems. And the terminology and basic concept of these vibrations. So in simple harmonic motion, you can say there is a waves is passing like this. So once the wave is passing like this, there will be, let x is the displacement of the point from this mean position of this after t time. So there is a point is moving on a road, or else there is a small paper if it is moving. Okay, then we can note down there is a motion is going to be happen with these small forces. So here displacement of the point P, which is from the mean position after t time. So mean position after t time means here is the mean position. Then check there is a upward layer, backward layer is there. So there is a positive sign and negative sign. Okay, negative sign and positive sign is there. So once it is passed through upside, then it will be having higher amplitude. And if it is comes to downside means there is a lower amplitude. And like this, the frequency is moving with the time variations. So once the time variation is going to be increased, then the wave frequency will also be increases. Like this, up to here, it is said that there is a one complete rotation is happened. Sorry, 1/4 rotation is happened. Then there is really, you can able to say there is a pi. Okay, 1/4 is going to be complete. There is a pi and 2 pi. Like that, similarly, if it is moving with this particular position to here and here, it is going to be move, which is 1 to 4 pi like this. One cycle also you can able to say there is a one cycle also, peak to end, it will be going to come one particular rotation also we can able to say into this particular systems. So into the x and x dash, x and x you can say there is a distance to this upper side, mean position to upside, that is called as a x. Okay, capital X. Okay, capital X is the maximum displacement of the point from mean position. Okay, maximum point of this from this mean position. X is the displacement of the point from the mean position to this with the time. With the over the time, we can able to say there is a x. Okay, there is a x is moving towards the with the time t. Okay, the equation here, displacement of the point, we can able to write it as in terms of x equals to x sin theta. X equals to x sin theta, we can able to write it because it is moving towards a sine wave. Okay, it is moving towards like a sine wave. So sine wave will be going to be like this only. Okay, then it will be called as a x equals to x in terms of time variance. So x sine theta will be going to be taken as x equals to x sine mu theta. In terms of theta, we are writing in terms of mu and t. Okay, mu and t is nothing but one of these displacement with respect to time. Okay, once the theta is defined, t equals t. See, you can check this. Theta equals to mu t. Okay, x is nothing but x of distance with a x into sine mu t, right? Sine mu t will be able to write it in these terms of by using of this circle equation, right? Circle to this, theta equals to omega t, theta equals to mu t, and there is a x distance equals to x sine omega t, right? So these are this equation for this natural basic concepts. So velocity we can able to define. Here it is a distance we are taking in terms of x. So x is nothing but here x omega t. Okay, and distance velocity we can able to write it in terms of d by dx, d by dt of x. Okay, d by dt of x means differentiation of this distance. And if you make it double dot, okay, so if you make it double dot, we can able to write it as a acceleration. Okay, if you make it as a double dot, we can able to write it as acceleration. So here in terms of x dot, we are replacing x with this w into x, mu into x of cos wt. Okay, which is from this previous equation, which is from this equation of this sine. So we have been differentiating this sine to cos. Okay, sine, once if it is differentiated, it will be going to become as this cos. Okay, and acceleration of this point is nothing but x double dot. It is already mentioned here. So it is already mentioned x double dot, which is a motion whose acceleration proportional to the displacement from mean position. Displacement from mean position means there is a, it is going to be happens like this, which is from the mean position, So acceleration, displacement from mean position, and this directly towards the mean position to this known as SHM, simple harmonic motion. So a simple harmonic motion will be going to taken as x double dot equals to differentiation of velocity. Differentiation of velocity will be given as a acceleration. So we are already have this d by dt of x equals to velocity. Once if we differentiate it again, d square by dt square into x, there is a double dot of omega n square minus omega n square. Here it is the sign. Once if you cos, if we differentiated, once if you cos differentiation is there, then it will be minus sign will be going to have come. So it will be minus omega square into sine omega n, omega t. So we can able to rewrite this one in terms of omega t. We can able to write in terms of x omega t. We already said that there is a x we have been seen. So here we are writing in terms of fundamentals of S system, x double dot plus omega n square x square omega square x equals to fundamental equation. So time period, we know that there is a 2 pi by omega. 2 pi is nothing but complete to one complete cycle. One complete cycle will be taken as in terms of 2 pi. So we can able to write it in terms of 2 pi by omega. It's a time required to complete one cycle, that is 2 pi. If there is a cycle is moving from this position to again, it is starting and ending. It is starting and ending position. If it is comes to the same position, we can able to write it as a 2 pi, right? Once it is comes to 2 pi, then it will be called as one cycle is completed. Okay, so how much time it has been completed? So once if it is completed, there is a time limit will be there. To know that, there is a equation that is called as a time period to complete the one cycle. So here it is a t suffix p equals to time to complete this period. So 2 pi by omega. Omega is nothing but we have been taken as a frequency of this particular, right? Omega is nothing but one of the frequency we have been taken as the displacement, right? So we have been taken into this frequency. So here it is a frequency, number of cycles per unit time. Here it is some reverse cases there, So there is a number of cycles per unit time is known as a frequency. So in this reciprocal of time period, we can able to write it in terms of 1 by tp. 1 by tp. Tp is already we know that there is a 2 pi by omega, 2 pi by omega. Once if it is frequency if you want, then it will be omega by 2 pi, it will be going to come, because it is a reciprocal of this time period. And amplitude is the maximum displacement of the vibrating body. It is called as a maximum amplitude, which is from this end to this end. Vibrating body from its given mean position to this maximum moving, it will be going to come like this. So stiffness is nothing but one of the property of the material which is produce an unit displacement in the direction of applied forces. So it is the force required to produce unit displacement in the direction of applied forces, which is nothing but a spring, stiffness of the spring. Okay, so we can be able to write it in terms of K equals to F by delta. F by delta is nothing but here it is a force applied on the spring, and K is the stiffness of the spring. And delta is the deflection of the spring. With one of the example, we can able to note that there is a degrees of freedom. Degrees of freedom we'll be going to discuss later. So one of the example we can able to write it in terms of stiffness of the spring. So here it is the stiffness of the spring we can able to represent in terms of K. Stiffness of the spring we can able to represent in terms of K. Anywhere we can able to write it as a F by delta. Once the F is given, we can able to find this K. We already know that, and delta we can able to find it. Or else delta, if it is given and force is given, how much force is required to move that, already we have been seen from formulas. So with this formula we can able to find the sum of the solution for this. Okay, so here is one of the degrees of freedom. We can able to see there is a minimum number of independent coordinates. Required to specify the motion or configuration of a system at any instant of time is known as this degrees of freedom. So there is a number of independents, there is a rotation, there is a motion in linearly. So here it is the one of the shaft is having the 1 degree of freedom, it is rotating towards the particular rotation, and there is a linearly moving motion. It is a rotation motion and it is a linear motion. It is a given example here. So in this 1 degree of freedom, there is a X is moving towards the downwards. Here there is a independent motion is 1. If you say there is a spring mass system having mass M1 and K1, spring K1 is there, and it is having the displacement of X. It is there. So independent is having the one coordinate, and one coordinate is having the single degrees of freedom. And in these 2 degrees of freedom, there is a K1 and K2. There is a K1, K2, and mass 1 and mass 2. There are 2 masses and 2 springs are there in this. Again, there is a force if it is applied, and if there is a force is applied, there is a 2 independents. One is over here, 2 is over here. Okay, there is a 2 independent systems are there. So then it is called as a 2 degrees of freedom. 2 degrees of freedom of the system we can able to say, because it can move either upward this side and either this side. So it may be a 2 possibilities are there to move the force into this any one of the direction also. One direction only, but it may be move continuously, or it may be equally, it may be moves. So we can able to write it in terms of it is a 2 degrees of freedom. And again, there is the same example which is having the 3 masses and 3 springs. Okay, and it is having the 3 motions. It is having the 1, 2, 3 motions. So we can call it as a 3 degrees of freedom. You can check this. There is a mass 1 is there, and the force is 1 is only acting on this mass, and there are 2 masses and 2 forces is acting 1 and 2. Then it may be moved towards this force, it may be moved towards this force. So it will be called as a 2 degrees of freedom. And individually, how many points are moving, independent or individually, how many points are moving, we can say it as a independent and dependent degrees of freedom. So I hope you are understanding about this degrees of freedom concept with the example. So here it is a damping. What is meant by damping? It's a resistance to the motion of a vibrating body. You know that it is a shock absorber, right? You may see that it is in the bike. Why it is required? While traveling, you may feel there is some roads are having bumps, or else a speed breaker time, or else there is some path holes. You may know that there is weather conditions. If there is a bad, then there will be some rough surface and smooth surfaces will be going to come, and hardness will be going to come. At the time, once if you feel there is a shock, or suddenly if it is having some up and down system, if it is happens, all the forces is going to be occurred on these bikes tires, right? So once it is transferred to directly to the tires, then it will be going to definitely break. So we require to make it as some maintenance, or else there will be some absorption of the energy, because sudden jump if it is occurred, then the energy storing system should be there and energy releasing should be there, like a sponge. If it is suddenly given a hit, okay, there will be suddenly given a hit, or else there will be some squeezing of the atom will be going to happen. Into this there is some fluid will be there inside, so that is called as in the terms of APU and some hydraulic fluid. So that won't be discussed here. So here the fluid will be absorb all the energy which is under these vibrations, and there is a sudden force. Sudden forces will be observed. Sudden forces will be observed into this shock absorbers, and which is causes the vibrating body to come to this rest position. So once it is observed, then the forces is going to be comes into the centralized, and once the spring is having absorbed all the energy and it is try to move to this original position, when it will be going to occur, then when the sudden forces happen, then it is try to squeeze the position, and suddenly it will going to be released. All of a sudden it will be going to release slowly. So it is nothing but the damper which will be absorb the whatever the vibration is going to be happen into this sudden forces, and damping system will be said in terms of C. So spring we said as a K, and damping in terms of C will be said, and mass in terms of F. Okay, these are the three are important in these vibrations. These are the three are important into these vibration systems, where the mass or spring and dampers are there. So we can able to find the force also. Once the force is given in the direction of X, then we need to find the displacement, velocity and acceleration. So the force developed by this, or a resisting force developed by this unit velocity, in mathematical we can able to write it in terms of F by V. What is meant by F? What is meant by F is nothing but force on the damper. The force on the damper if we applied, and velocity of the viscous fluid. As we said, there is inside there is a liquid will be there, fluid. The fluid will be there. That viscosity of the fluid will be there. So we need to find what is the viscosity of the particular fluid, and we can able to check this as a C equals to F by V. So C is nothing but damping force, damping coefficient. Once if there is a damping is going to be occur, there is a force by viscosity, we can able to write it. So what is the unit for this? So newtons per second meters. Newtons per second meters is nothing but coefficient of the damping. Okay. So once the coefficient of damping and damping system if it is known, then we can go to this particularly what is meant by resonance. Resonance is nothing but once the frequency of the external excitation, like if there is a body is heated by some object, okay, the object is heated by some this object, then it is try to vibrate with the natural forces, and if the body is going to be having some vibration, with that vibration, and it is try to excite another building or else another same type of thing, and it is called as resonance. So like one of the exercise has been happened into the previous history. There is a bridge and number of soldiers are passing over there, and early morning will be there, and the bridge has been given some natural frequency. Okay, natural frequency is there. The same type of natural frequency by this parade. The parade has been happened, and with the natural frequency equals to this parade, so there is a collision happened and resonance happened, then bridge has been cracked all this. So it is one of the historical event which is happened into this Europe. Okay, with this we can know that one of the vibrations which is having resonance is one of the important topic, because once any body or else fork is here, tuning fork, once it is excited with the same sound waves with the distance we kept, then it is tried to vibrate here without giving the any input to this. Okay, here the input is nothing but sound waves. Sound waves are traveling towards this. Sound waves are traveling towards this with the tuning force. So here it is the external excitation force acting on a body is equal to the frequency of vibrating body. The body starts vibrating with a extensively large vibrations, large amplitude, such state is known as this resonance. Right? Once there is a excitation is happened to the about a tuning fork, and with this tuning fork, what are the vibrations inside this, it is going to be produce some sounds, and these sound waves are given to this input to this second tuning fork. So second tuning fork will automatically vibrate with the same frequency. Same frequency will be work. Same frequency will be going to work, and we can able to see there is a resonance is occurred. Resonance is occurred. With the Tacoma bridge, we can able to see one of the parade is also happen with the large vibrations, and we can able to see there is a bridge has been collapsed. Right? So element of these vibrations is nothing but M, K and C. M is nothing but mass, K is the spring and C is the damper. Okay. So here is the M for this storing of the kinetic energy, and K is the spring for this storing of this potential energy and supports this loads, and damper is nothing but dissipating of the energies and cannot be support this loads, and dissipating of energy will be going to be happens and cannot be support these loads. So in spring mass systems there is a damper, spring and vibrations of this body, we can observe all this. So in damper energy cannot be observed in this, and spring also, which is having supports only. Okay. So what is meant by equivalent springs? So in this equivalent spring there is a springs in stresses and springs in series and parallel. So one of this example you can check this, in this deflection of the equivalent spring we can able to write in terms of two terms. There is a series and parallel. There is a series and parallel we can able to see. So in this series there is a distance displacement will be deflection going to have occurred as a delta. So in the displacement 1 and 2, deflection to this 1 and 2 we can able to calculate as a summation of these displacements, or else deflection of this 1 and 2. So we can able to simply by adding these two springs constants we can able to write it in terms of as a only one spring which is equivalent. K equivalent we can able to write it. So here it is the force in the equivalent spring we can able to write that there is a spring force in 1, forces on the spring 2, which is nothing but M equals to mg equals to mg1 and mg2. So here it is the mass is same we have been taken. So springs only we have been taken as a different as a equivalent one. So you can write this, the system have two springs in series and has to be replaced by an equivalent spring stiffness as a Ke. Equivalent stiffness Ke, we can able to replace it, right? Once it is replaced, we need to write this as a Ke, because Ke is nothing but K1 plus K2. Ke is nothing but K1 plus K2, we need to write it because it is in series form. Okay, because it is in series form. So deflection of the equivalent spring, we can know that deflection of the equivalent spring of 1, deflection of the equivalent spring of 2. So we can able to write it in terms of deflection equals to deflection 1 and deflection 2 in these both springs. So here we can able to write it in terms of mg by ke. Here we have been taken as mg by ke plus which is equals to m1g by k1 plus m2g k2. So we have been taken as k1 and k2 as a ke. k1 plus k2, k1 plus k2. You can check this. This k1 and k2 we have been written as in terms of ke here. So m is same, but masses is same and spring constants are different. So spring constants we have been taken in terms of equivalents. So here, but mg equals to mg1 equals to mg2 equals to same. So here is the masses are same, but only the spring constants are varying. Substituting into this C into this B. So C into this B, we can able to write it in terms of K equivalent, which is 1 by Ke equals to 1 by Ke equals to 1 by K1 plus 1 by K2. We already seen that there is a spring constant equations. Once it is in series, we can able to write it in terms of deflections. We can able to write it adding of both the two. Okay, and while substituting K1 equal 1 by Ke, we can able to write it as a 1 by K1 plus 1 by K2. The both things we need to be remember, which is under 1, under 2 positions. Okay, and where the spring is in parallel. Once the spring is in parallel, you can check there is a spring 1 and spring 2. There is a spring 1 and spring 2 has been given with the deflections. So which is equal we can able to say, because it is in parallel. So once there is a mass has been suspended, then it is try to move with the same force of amount of forces it is try to bring back. Okay, here deflection is going to be occurred with this masses. Deflection is going to be occurred, right? It will be same. Deflection 1 and deflection 2 will be same if the mass is having some forces, right? Deflection 1 and deflection 2 will be same. Equivalent of the spring will be saying that spring on this force on the spring 1, spring 2 will be plus equivalent forces, which is nothing but here mg we can able to write it in terms of m1 plus g, m1 into g plus m2 into g. So here the spring mass substitution will be going to be happens. We can able to write it as in terms of delta equals to delta 1 plus delta 1 equals to delta 2, because there is a delta 1, delta 2 are equal, because it is pulling at a time both will be going to be fetched at the same distance. Displacement will be going to happen, and we can able to write it as a delta equals to delta 1 equals to delta 2, right? So substituting into this d into e into f. So e into f, if you say that there is a Ke equivalent of spring will be taken as K1 plus K2. Here the K will be going to be Ke will be going to be happen. Ke will be going to be happen in terms of plus. Previously, if you check, there is a Ke equals to, it is under 1 by, it is there. 1 by will be going to be happen into this series. Series means you can check this, 1 by will be going to come. 1 by will be going to come series. In parallel, there is a directly 1 plus will be going to come. So we'll be going to stop it today up to this. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.